Hi, my name is Junko Yoshida, Editor-in-Chief of the Ojo Yoshida Report. Thank you for joining us today for the Software-Defined Vehicle wrap-up session. We will offer this in a pre-recorded video format. However, please note that we will have a live Q&A session right after this video. NXP is where the future of automotive begins. Designed to scale and evolve, NXP's system platforms are the foundation for every vehicle architecture. We are innovative collaborators, propelling you forward to spark growth for a future that's dynamic, safe, intelligent, and electrified. Let's redefine automotive together. Thank you very much for coming to this wrap-up session on software-defined vehicle. And this has been a fun. For the last more than 6 weeks, we had various guests talking about SDV. Everybody has a different definition of SDV, and everybody has different take on SDV. We'd like to come to a conclusion, maybe not a single agreement, but to understand where the problems areas are and where the industry needs to focus. But first, let me introduce all the great guests that we have. We're going to go by the alphabetical order. First, Phil Amsrad is Associate Director responsible for automotive at S&P Global Mobility. And next, we got Sebastian Klamajiran. He is the Senior Vice President Automotive System Engineering and Marketing at NXP Semiconductors. Hi, Sebastian.
Good morning.
Okay, and we've got Phil Kopman. He's a professor at Carnegie Mellon University who actually teaches embedded design. So we got the perfect guy who knows something about embedded systems from the design perspective. Hi, Phil.
Good morning.
All right. And then we have Bolaji Ojo. He is a co-founder of the Ojo Yoshida Report, and he's a publisher and managing editor of this publication. Hi, Bola.
Hi, Junko. Hello, everybody. Looking forward to this. And I'm not going to jump in right away, but that's a question that's itching somewhere in my brain. So I'm just going to reserve it until Junko launches into the wrap-up.
Okay. You know, I'm going to really start from the very beginning, and I am going to be very honest that maybe I think I was very naive, but when I launched this SDV, Software-Defined Vehicle podcast series, I thought SDV was already here. So I was kind of surprised, and when a lot of people kind of corrected me that no, we're still in a very early stage. Actually, that wasn't even part of my first question when I started this series. And I think when I was interviewing Sebastian, I asked Sebastian, you know, just off the top of my head, it's okay, where do you think we are? If there's an SDV mountain to climb, where are we? And Sebastian was very straightforward. We're in a very early stage. And I said, what? We're in a very early stage. So let's start from there. What is making SDV mountain climbing challenging? It's a loaded question, but also I think this sets the stage where we are today. And then we can dive into some of the problem areas. Who wants to take that first?
Maybe I can start, Junko, on this one, as you raised my name already in the question. Yeah, indeed, from my perspective, SDV is still a big journey in front of the ecosystem. Already many years have been spent into working in implementing the first step toward SDV, but from my perspective, we won't see a true full SDV vehicle in the road before years. And the reason for that is actually the complexity of implementing an SDV. So you have already cars who can do over-the-air update and which are there and update your security on your car, but it doesn't make it a full SDV car, right? It's just one of the features of SDV getting implemented. Until you get really a full access to all the data into the car and getting access, being able to extract those data to the cloud, being able to use algorithms, process them, send that back to the car, and bring new services to the end users, I think we'll still see years before to be there. And the reason is that we are coming from an automotive ecosystem, which was mainly a mechanical ecosystem. And this ecosystem has to learn about software, about the complexity of this software implementation. So we need an evolution in term and a learning phase within our ecosystem, which is really ongoing right now. Lots of excitement, lots of expertise getting built, but there is still a lot to be learned and to be built in order to be fully successful.
You know, Sebastian, the fundamentals that you explain now is quite interesting. And throughout the series, there's an assumption that SDV is inevitable. Should we assume that?
Oh, I definitively support this statement. It is inevitable because today the architecture of the vehicle are too complex. It's just unmanageable going forward. So if you want to be able to have a total cost of ownership when you build your car, you in any case need to review your car architecture. And by doing this car architecture refresh, you are going basically to implement the next step toward your SDV foundation.
If I can comment on that, another way to look at that is all these features. If you want all these features, SDV is a way to make it less painful to get them. But to your point, Bola, that doesn't necessarily mean everyone wants all those features, but we're assuming that everyone wants the features. And if so, SDV is sort of what the industry wants to do to make it viable.
Interesting, Phil. So is there, well, I think you actually, during this series, we outlined some of those features that you talked about. So is there kind of like a pyramid of which features we think form the baseline and which ones are the aspirational features?
Why? What do people want to pay for? So in a car, a feature is anti-lock brake is a feature, and automated steering is a feature. Just so we have the terminology straight. And so car companies like to sell features because they can charge money for features. And if you pile enough features on, and each feature comes with a box, you end up with this big mountain of boxes. And everyone then wants to say, well, let's have one box instead of a bunch of boxes. And what the car industry is doing has played out in other industries for decades. I've watched this played out in other industries for decades. And there's a pendulum that swings back and forth. They all pile into a central box. And then they say, oh, that's too unmanageable because complexity. It'd be smarter to have more little boxes. And it just comes in and out and in and out. So we're just watching the pendulum swing hard towards central box in automotive now.
And maybe, Phil, you mentioned, is there an interest for the feature by the end user? But for me, SDV, there is two aspects of it. There is indeed the end user use cases application, and there is the OEM needs anyhow to implement it because you need to be able to update your safety and security like you are doing on your phone every day, right? So
that's a fair point.
Capability is required. So that's why, from my perspective, in any case, SDV will happen because there is this fundamental that the OEM needs to have into their car, and then the services come on top of it.
Although if everything weren't interconnected, maybe that security stuff wouldn't be as on fire as it is now. Although I'm well aware of the CAN message injection attacks happening across the world. I get all that. But with the internet exposure, you have no choice. There's no discussion to be had. You have to do it.
Yeah, Junko, I don't want to disagree with your premise. I just want to take a slight twist to it.
Sure.
Because I think one of the things the industry did kind of to its detriment with self-driving was we started talking about self-driving cars like we were talking about trying to get to the summit instead of what are all the steps that we need to take to get there. Because if you just try to assault the summit, it's a monumental task, and it seems ambitious but impractical. I think the software-defined vehicle is going to be the same way. It's an appropriate model to talk about summiting it, but we've got to talk about the incremental steps that we're taking. So in that regard, I think we would all agree Tesla's as close to anybody right now as to having taken the early lead in SDV. And then there will be, typical in the industry, they'll push until somebody leapfrogs them. Maybe it'll be, some Chinese OEM. And then we'll get there. But it's going to be a number of incremental steps necessary to get to that summit. And when we as an industry talk about, oh, it's going to be great when, we're at the top, we kind of lose the effect of it's going to take a while. There's going to be a lot of false starts. There's going to be a lot of hiccups along the way, but that's okay because we're slowly moving in the right direction.
Yeah, that's I'm really glad you point that out. That is true. It's part of the media's habit. Let's set the goal and let's figure out who is top, and then let's do the horse race, right? I mean that is the really the I can see the kind of occupational hazard that we suffer. But let's go down a list a little bit, because I think you're right. It is an incremental steps, and the incremental steps, each step is very important. And one of the things that was brought up also by many people on this series was the topic of sharing hardware resources. This becomes possible because if you're trying to put together different ECU boxes, there's into one gigantic SoC or whatever, that means that the different functions begin to share memory, processing power, interconnects, so on and so forth. And the thing that struck me then is this seems like really the source of a lot of problems that people are having, because it is easy to say that we share the hardware resources, but what functions are sharing the same resources, and what is the criticality of each of those functions? So can you sort of educate me kind of as a roundup? What are the booby traps laid out by this so-called sharing hardware resources? Booby trap?
Sebastian, you want to start? I can do a real high level overview, and then you can go into the details if you want.
Yes, go ahead, Phil.
So I on the one hand, from the OEM's perspective, if one of the things you want to achieve with SDV is cost reductions, and I think we would all admit hardware is one of the driving forces behind cost increases over time. If I can go from 3 MCUs to 2 MCUs, if I can go from 64 gig to 32 gig, those things appear to be opportunities for cost savings because I'm taking hardware away. And the whole idea of I go from 100 ECUs to 10 ECUs to one central computer kind of fits in that same idea that I'm taking physical stuff out of the car, replacing it with more powerful electronics. So that's the appeal behind it. But with that, if you're taking things away, part of the promise is, well, because things can share those resources. And that's where I'll step away and let both Sebastian and Phil talk to it, because I think they spend a whole lot more time thinking about the security concerns of that sharing than I have.
Yeah, indeed, Phil. When you think about the combination of multiple ECU into one single component, the key concern is the isolation between the different information. And by isolation, it means basically you need to ensure that the different resources from the component are really used for only one unique purpose. So the resources can be the IOs, can be the memory, can be the processors themselves, but you need to ensure that once you run your ECU on this SoC, those are isolated and are not accessible by the other application. So this is fundamental actually in the design of the components which are going to be used in automotive. So this is intrinsic actually to the way an automotive chip will differentiate from a generic microcontroller which is not automotive specific. So what we have been implementing actually in NXP, and we did the announcement 3 months ago, is that the latest S32N, which is a 5 nanometer processors, is actually having all those resources distribution and isolation deeply implemented on the hardware, meaning that from the pin up to the core of the microcontroller, you can define at the start of the component a full isolation of the different resources. And that's what actually is essential for the OEM in order to bring this safety and security across the multiple application. And that's as well a key element because the software we are going to run on the SoC will come from different providers. So you need to be able to make sure that when you work with a broad ecosystem of different software players, different software partners, that you protect their IP, and then that you ensure that their IP are not interfering with each other. So that's definitively the key value proposition that each OEM need to really focus on when selecting its hardware components.
I have to add on top of that. So Sebastian, everything I'm going to say you already know, but I need to make a point of some of the safety stuff. When you talk to an OS vendor, which NXP is not quite, right? If you talk to an OS vendor, they'll say, well, we have to ensure non-interference, that nobody steps on someone else's memory and everyone gets the amount of CPU so they hit their deadlines and all that. But there's a next level which the chip folks deal with. For example, making sure that if a chip has two independent things, it better have 2 power supplies. Because if it doesn't have 2 power supply pins and one of the power supply pin fails, most chips have many more, I'm simplifying. But if the power supply inside the chip fails, both halves go down, that's a problem. And so if you're an OS type person, you say, well, we have to protect resources. But if you're a safety person, you say, well, the resources are just the start. What about all the failures? How do you have common cause failures? What about the power supply? What about if the non-critical part of the chip uses a lot of CPU and heats the chip up to the point that you have to throttle the clock on the other half of the chip because the chip's running too hot? And those are the kind of things safety engineers worry about, and operating system vendors maybe not so much. And what if I had a desktop computer where all the capacitors exploded and plastered themselves on the other side of the box. And it was a batch failure, so all my computers did that. That was entertaining, right? Common cause failures run pretty deep. What if the thing pumping power in? So now you don't need just two sources of power for the chip. You need 2 sources of power for the box if it's an autonomous vehicle driving you down the road, because if the power cable fails at some connector and you lose power to the box, well, guess what? You have no computer driver, and I don't care how many chips you have inside, they're independent. So the safety folks take that question of isolation and go all the way up to the system level, saying if it has to work, it's really got to work, and you have to make sure. So you end up with the battery on one cable and the generator or the alternator on another to make sure that if one goes, you still have the other, and the alternator can't take down the battery. That happened in one of my cars. There's all sorts of stuff. So when you say isolation, it's a really deep well you got to dig down in well beyond the chip when you're at the automotive system level.
Yeah, that's kind of interesting. What Phil Amsrad originally said, this sharing hardware resources kind of drove the idea, that made OEMs feel comfortable. Oh, we can do the cost reduction. And here comes Phil Copeman saying that, well, it's not that simple. Not that simple. It could actually end up adding more hardware in a way to secure that the interference or the unintended interference would not occur, right?
I've done these studies for other systems, and what we find is everyone has a strong opinion that either distributed is better or centralized is better. It changes over time. And whatever distributed is, if centralized is better, they overlook the fact that now you need 2 power supplies, you need 2 sources of cooling, you need 2 of everything. because they just looked at the old box that didn't have all that, right? And then when they say, but our distributor will be better, they say, all right, yes, you can buy 10 cheap chips less expensively than one big chip, but now you have to put a box around each one of them. You have to have a circuit board. You have to have cooling on all of them, right? And so in my experience, it ends up being a wash from the bill of materials. The bill of materials, I've never seen a system where bill of materials was the compelling reason. The reasons always had to do with things like system integration, diagnosability, flexibility, which is the point for software-defined vehicles. Now everyone's going for flexibility. Well, that's a smart thing. You might actually get flexibility. But bill of materials costs, now in cars, maybe it turns out, this year it's cheaper, 10 years later it's more expensive. The pendulum swings back and forth, right? And so I'd encourage people not to get distracted by bill of materials and instead ask what's the core value that you don't have to have a 10-cent win on hardware costs, that there's a core value that just makes it worth regardless of the cost.
Phil, but when analysts, sorry to put anybody on this, but when analysts look at all of these issues, they consider the bill of materials. They consider—
That's what everyone does. That's what everyone does. And it's the last thing you should be worried about, even though I know automotive is all about the BOM cost. I know this.
So how do you factor that into the decisions that OEMs have to make?
Well, what do they want? I mean, if they need centralized architecture for updates and they need it for flexible software, that's a great reason to go centralized architecture. Of course, they want to squeeze cost out, but they should not be surprised if it's harder to get it cheaper than they thought.
Bola, if I can jump in there, I was thinking about this last night, that it kind of feels like I make the analogy between SDV and quality, where decades ago, when quality was the thing that everybody was starting to focus on, that there became a mantra of, well, you have to build quality in at the beginning. You can't test it in at the end. And I feel like we're kind of at a same juncture right now with SDV, that if you think of SDV simply as, I'm going to take 100 controllers and I'm going to squeeze them into 10, well, you haven't really designed in SDV at the beginning. If you're going to really build SDV in, you've got to take what Phil's talking about, what Sebastian's talking about at the beginning of the development evolution, and make sure you're covering your performance requirements, your reliability requirements, your safety requirements, and make sure that you're covering all those bases up front, as opposed to finding out at the 11th hour that, oh my God, I did a FMEA, and it turns out that when this happens, the car just stops.
If I can say that from a different direction, the worst mistake you can make is to take a highly distributed architecture and smush it onto a single computer. And the second worst mistake you can make, actually the even worse mistake you can make, is to take a centralized architecture and try and spread it out on 100 distributed computers. Neither one works. And Phil, I'm agreeing with you. Basically, The architecture has to be a match for the physical and software architectures have to be compatible, or it's just not going to work. So if you want to make a big change from distributed to centralized, setting up a bunch of microservices and a bunch of middleware to make that happen is not going to automatically give you a great architecture.
There's a practical person here who lives it. Sebastian, you're jumping in at the right time, so sorry to put you on the spot. You live this, so tell us, what's that conversation like?
Well, I like to actually chime in here, because the reason why we want Sebastian to answer this question is that of all the companies that I interview, I talk to a lot of automotive chip companies. NXP is one of the companies who's most judicious about what central compute is for the next generation automotive architecture. What it can, what it cannot do. So maybe it's really a good segue for the Sebastian to weigh in.
Yeah, thanks, Junko. Actually, I agree with what Phil and Phil said, that you can't decorrelate SDV from the physical of the car itself. And the challenges that the OEM are facing today is that they are not developing only one car. Most of the legacy OEM have to deploy an architecture which goes from a category A to a category D, which have a different physical complexity, different number of features or functions in the car. And so saying that I will get one architecture which will fit all is just not realistic. So from my perspective, there will be an evolution in the SDV definition, and you can probably think that the higher end vehicle will go first in SDV because they have less cost constraint, while if you go to a class A category, actually the priority for the OEM is not to make sure that it can reconfigure the vehicle by software. It's first to get a cost efficient solution. And the architecture might be different, or actually is different, and that's what the OEM are struggling with, because many of them opt that with SDVs they will solve the cost and the benefit, which didn't happen. So what we see now is that many of the OEM have realized that. And they are differentiating their high end toward a full SDV capable and the lower end of their range with something which is more cost efficient, starting to centralize, analyze, but at a different speed.
I've seen this happen in other industries as well. They say we're going to have one really good central computer and we're going to put it in all our products, and we're going to have one peripheral and put in all our products, and they immediately hit the wall of their cell that they have to size it to work for the high end. So that makes it expensive. And I'll just make up numbers. If your product mix is 1% high end and 99% low end, and all the low ends have to pay the freight to be the same as the high end, that's not going to work, which is exactly what Sebastian was going after. And I always end up recommending you're going to need either a high or low end architecture, or most companies that have a lot of sophisticated products, they actually need three architectures. They need a high end architecture, they need a medium, and they need a low. And that means all the things they said they were going to get will reduce spare parts inventory because we use the same spare parts for everything. That just never works because they can't afford the high end spare parts. And then they have low volume for the high end, which makes it even more expensive. And, those exercises always sound great on paper, but they fall apart with the reality that you can't afford the high volume, high cost to have the same parts everywhere. So you end up usually with high, medium, low, which is better than 73 different architectures, make no mistake. Yeah. But it's never going to be just one. It's just not going to happen.
Yeah, and the key point, knowing upfront that you might have 2 or 3 different architectures, then is to think about the total cost of ownership. That the software you are going to develop might be based on different hardware in order to get the scalability. But you really have to think from the start on the software scalability and the reuse between the different architecture, because that's where really lie the total cost of ownership optimization. And that's definitively something with our partners we realized when having our engagement with the OEM, and that's one of the key elements we are pushing with SR32 CoreRide platform, which is exactly bringing this scalability across a very broad range of processing, which can serve a low end toward the high end, depending on which product you are taking. And that can be enabled if the OEM are looking at the synergy at hardware and at software level to make sure they can reuse and easily develop and port their different application software across the architecture.
One of the discussions, in some of these discussions, we also talked about the software expertise at the OEMs themselves and within the ecosystem. So I guess my question related to the answer you just provided now has to do with what is the landscape now from your perspective of the software level and the decisions that the OEMs have to make?
I mean, besides CEOs getting fired over it? Other than that, it's pretty bad, right?
Yeah. So
I can say more, but maybe the other guys want to say something snarky first. So go ahead.
During a number of the episodes, cultural and organizational issues came up as either an impediment or an enabler. I think this is a case where, they're probably more on the impediment side right now, in that, I think everybody wants to be in the software business, because there's a lot of value. You can see that the software value is growing tremendously more than the hardware value is. And if everybody looks at how they can maximize their piece of the pie for that, it's natural for the OEMs or anybody in the supply chain to say, how do I take the sliver that I have right now, how do I make it a little bit bigger? The problem is, and I think, Junko, we had talked about this last year at NXP Connects, where a distinction was made between coders and software architects. That there's a lot of coders, there's a lot of people that can write lines of code. There's a relatively small number of people who can really put together a software architecture. And what we have right now as maybe an industry challenge is everybody's got coders. You read articles about we don't have all the hardware guys that we had that we don't need anymore. We're going to turn them into programmers. It reminds me of when we switched from analog to digital. Not everybody's skill set that was well tuned to one is going to be well tuned to the other. And what they need is not guys writing lines of code. What they need is people that are really architecturally savvy to be able to put these systems together. And I think that's where the real deficiency lies within the OEMs, because they tend to focus on numbers. We've got 1,000 software engineers. Well, you got 1,000 architects, or you got 1,000 guys that are just pounding out code.
Yeah. Well, this is exactly the Phil Koopman's wheelhouse. Let's hear it.
Yeah, buying software engineers by the bushel is not necessarily the correct unit of measure, but it's happening for sure. I have a slightly different take. In my experience, a good, solid computer engineer is more likely to be a good architect than someone who got taught how to code, because if you're building system on chip or using them, if you can't do levels of abstraction in architecture, you're not going to survive, right? I started out life as a CPU designer. My job after that, I got hired in to not do CPU design, and my boss said, no, I hire CPU designers because they understand abstraction. That is a factor. But I would say the glorification of coder as software engineer is really hurting everyone. And if you hire the smartest people in the world and you have lots of resources and you just beat the problem in a submission, you can make a ton of money, as we've seen, right? But not everyone is the smartest. I mean, even at my university, it is not the case that all the children are above average. That's just not how that works, right? And we pride ourselves on being elite, but there's somebody who graduates at the bottom of the class. That's how that works. There's no way around that. So the issue is, do they have the skills they need, and are they teaching the right skills? And glorification of coding is not teaching the skills to deal with complexity. And the problem here is not pushing out lines of code. The problem is having the right architecture, managing complexity. It's been about managing complexity since the 80s, when DoD, the U.S. Department of Defense, declared a crisis, right? Back in the 80s. This has been, every industry hits this. They get too much software content for brute force and small teams of smart people. Software complexity is hard to attack via sheer scaling. There we are. The thing next to that is there's an organizational component. So when you had a predominantly mechanical, electrical, lots of car folks have a mechanical background, they have an electrical background, they have a controls background, but it's the mechanical or electrical controls. There are software people there, to be sure, but that has not been the tradition, which means the senior folks have less software because it takes a while for them to rise through the ranks. But the thing you get is, if you have an organizational architecture that's not suited to software, you have a problem. There's a thing called Conway's Law, and I'm going to change it just a little. I'm going to reinterpret it just a little for this situation, that there's an equivalence between the structure of the organization and the structure of the system you built. And if you have a system built for mechanical, electrical stuff, you're going to have problems if that's a bad software architecture. If, on the other hand, you come from the software world and you have a a very distributed, middleware-based, everything's going everywhere kind of architecture, and you build an organization that looks like that, that can also be problems. I've seen that one cut both ways, depending which company we're talking about.
That is, that was actually, I'm glad we are talking about this, because that was one of the things that really surprised me, because I'm not an engineer. And when Phil Amsrod mentioned this thing about the organizational challenges, like, God, I can't get that. I understand that how humans actually get this, the silo system. And if my box needs to be merged with another box, I will do my best to protect my box, right? I mean, it's like I'm not going to be laid off by doing this stupid integration. But anyway, that's a human element. But okay, so this is really interesting. So we're talking about Phil just laid out two different approaches to the system architecture. So Phil, you were saying that there are actually two things that are going on in parallel right now.
Well, you're architecting a system and you're architecting the company that's engineering the system. And if they're incompatible, you're not going to make it. And too often, well, and there's also a third part, which is the industry legacy. But too often people see this as a technical problem instead of a system plus organizational co-development. The third one is that the Silicon Valley side of things is not used to doing with life critical systems. And the Detroit side of things is, but they're not used to dealing with highly scalable software. And so how do you integrate those two points of view within the same organization as well? So this is I've been saying it's a generational change for both industries to get the software folks into life critical and to get the life critical folks into software. They both have to happen. You have to end up, and that's an additional constraint on the organization, because if everyone's responsible for safety, no one is. And if the safety people don't get a vote at the table, you don't get safety, right? So that's a three-dimensional set of constraints. And why on earth would anyone expect that to be an easy problem to solve?
Yeah, I'm being simplistic here, but OEMs, the traditional OEMs, they didn't really have semiconductor hardware background. They also didn't have software background, but they work with companies like NXP, which is good on the hardware side. And I believe, Sebastian, maybe you can address these, what you guys have been doing on the software side, also bringing the two together to help the OEMs.
Mm-hmm. So indeed, specifically the legacy OEM were relying a lot on the tier one in the past, and the tier one were the one having some of this subsystem expertise and software experience. What we have been doing on the IC side, on the component side, actually, is to onboard more and more software in order to enable the products. So first internally, so we today have, for example, as many software engineers as hardware engineers, as to the point of Phil, as many software architects than hardware architects, because that's a very important point indeed. And we are working with a very close partner ecosystem in order to enable the software on our product. One of the, I would say, mistakes that some OEM did at the beginning, they wanted to do the full software stack by their own. They wanted to have the full control of the software, but starting from a point where they have very basic knowledge on software, and they failed. And I remember 3 or 4 years ago, when there was a SDV start, everybody was saying there will not be enough software engineers in the world in order to support all the OEM. That's probably true if every OEM is doing everything by its own, but it's not scalable. So it's our duty as component provider actually to provide more than the hardware, and provide all the software up to a certain level together with our partners in order to get the OEMs really focusing on the value added, on the application layers. That's really where their differentiation will come from. It will not coming from which real-time operating system or which Linux is on the chip, right? It's not what is going to change the performance of the vehicle. It's really which dynamic algorithm have they implemented, which ADAS solution do they have. That's really what's going to be, what should be their focus today. And that's really where we as a company are evolving. We are going to provide more and more software enablement in order to relieve the OEM and get them focused on what they need to focus on.
Hey, Bull, can I push back just a little bit on one of your assumptions? Because when I graduated college, I went to work for General Motors, and they had a fab. So that was a point when the cool kids were all vertically integrated. General Motors eventually jettisoned that strategy, but now we kind of hold up Tesla as the example of, well, this is how a car company should be run. They're kind of vertically integrated back to that old model. Now, they may not have a fab, but they're defining the hardware, they're defining the software, they're creating some of that stuff. So I don't think it's the case that the OEMs didn't do that. It's the case that I think one of the challenges that the industry has right now is the OEMs have to get out of their the model of being a transportation company or a car company. And I think of the analogy that was used back with railroads, 100 years ago, that they saw themselves as railroad companies instead of transportation companies. And because of that, aircrafts were never part of their strategy, or air travel was never part of their strategy. Whereas if they saw themselves as transportation companies, I wouldn't fly United, I would fly Burlington Northern, perhaps to get from one place to another. I think the car companies are kind of at a similar juncture right now. When we talk about basic transportation of how, if the car is simply a means to get from point A to point B, there's a lot of the stuff that we're talking about in SDV that doesn't look like it really is essential. But as the OEMs are trying to transform themselves from being car companies to whatever the next step in their evolution is, that's where it's interesting, but also difficult to figure out, well, what expertise do I need to have? What's my core objective versus what expertise can I go buy from somebody else because I need it, but I don't have to do it.
And that's complicated by the fact that the OEM needs enough software expertise to manage the suppliers, even if they're doing software.
Exactly.
And so
Yeah.
I did some benchmarking, and it looked like if you were a system integrator for a ground vehicle, not just cars, you needed about 10% of your engineers to be system and safety engineers. And all the companies I've looked at are staffed way below that, because what they were doing was basically renting out the staff at the tier ones to make those numbers. And if they want to disintermediate the tier ones, they're just dying because they don't have the system engineering, they don't have the safety engineering. And by the way, if you're a good software system engineer, what incentivizes you to work for a company that doesn't actually write software, but you're still needed there? What's the career path? How do you get the new folks there? How do you incentivize them? I'm not saying that you should not work. I mean, it's an interesting career path to work as a system integrator, but it's not a natural thing to just have it evolve. You have to really sit down. And right now, I'm not seeing the OEMs really put the resources into that when they're working with suppliers. Now, if you're vertically integrated, that argument kind of goes away because you have it all. But then you hit what Sebastian talked about was, guess what? You can't. How do you stand that up from nothing and displace all your tiered suppliers? What do you buy? You buy a tier one, I guess, is the only way to do that, right? After they got done selling off the tier ones, now they have to go buy them again.
Wow.
The question I had in mind about why, at the beginning, you all said, look, we are just at the beginning. We're just at we're at the bottom of the mountain. And you just, Phil and Sebastian and Phil, you've just kind of outlined why we are at the bottom of that mountain. It's such a long way to go. It's not just within SDV itself. It's also about what's happening to these automotive companies. What are they going to turn into? What are they going to become in the future?
Yeah, one reason to say it's at the beginning is you hear car companies saying, we need to get more software folks. Give me 10 bushels of software folks. And I'm there, to be clear, some companies are much more sophisticated than that. Not all, right? but even to hear anyone talk about that tells you we're at the bottom of the mountain.
Yeah, and maybe we are a bit too black and white. I mean, if the mountain is the Everest, there is 5 camps to go to the top of the mountain. I would say we're probably between the camp 1 and 2, and some are maybe at the camp 2, some at the camp 1, but we are already on the way to the top of the mountain. But it requires, we know as well that the camp 3, 4, and 5 are the most challenging one to go to. So there is still a big challenge in front of us. And from my perspective, Phil was mentioning the definition by the OEM. From my perspective, in order to be successful going forward, it has to be a co-definition between the ecosystem players. The OEM are speaking with the hardware manufacturer, are speaking with the software providers, and we have to co-define what are the next solutions. It cannot be just selecting on the shelves what are the products available and I build my car, because that will be for sure not optimized. So the ecosystem is large enough to have those discussions, and the competencies are distributed. Every player in the ecosystem is stepping up in terms of system expertise. And that's allowing different level of discussion between an OEM, a tier 1, and a semi-vendors. And that's thanks to this exchange and collaboration that we'll be able to be successful from my perspective.
You know, I want to jump in here, because that was one of the things that, you know, everybody talks about ecosystem, and ecosystem is a catch-all phrase to make everybody feels better, because, oh, we're all working together, right? And so we will come to a good solution. But it's really much harder than that. And I was going to ask, because this also came up during the conversation, I was going to ask Phil Amsrud, you know, can you tell me that the you know, how, because roles of the each partners in the ecosystem play have dramatically changed, or maybe not so, but it's like it is changing. So if so, how do you divide and clarify the responsibilities among OEMs, tier 1, software suppliers, middleware companies, chip vendors, you know, to help design software defined vehicles? I mean, is there clarity, I mean, among them?
Is there clarity, and can I provide it? That's a good question, and I'll use a bad joke that I like to use. Imagine the first SDV car is out on the road, has an accident. The people involved with the accident sue the car company for some reason, and they go to court, and the OEM has to put the experts on the witness stand to be able to explain how that car works. Well, in the romantic past, there were a handful of people that would say, I know how that car works. You know, you can put them up there. In the future with an SDV, it's like, ooh, is there a courtroom big enough in the country that all of those people that were involved with the architecture, the hardware development, the software development could all fit in one room, and they could stand up and testify to their small portion of that system that they're responsible for. And when it was all done, how would you determine who was responsible for the entire system? And I think that's kind of the image that I have to your question right now, Junko, is we need all of these people, kind of the links in the chain to be able to put it all together. Yeah. I've yet to figure out who's responsible for the whole chain. Because, you know, as we just talked about, with the software expertise not residing in the OEMs, can they really be responsible for the software? And if they're not really responsible for the software, they're relying on somebody else to provide that. It really convolutes the equation of who's responsible. And I'm struggling with an answer because I don't know that there is one at this moment.
Well, let me add to that and add an observation. If you can't know whose job, who is responsible for a problem, you have a bad architecture, and bad architecture is going to get you into trouble, right? And we're back to the OEM has to have system engineers, because there should be 1 or 2 system engineers at the OEM who knows everything. And if they don't know it, they're not doing their job. So I think that reflects poor architecture. I'll point out people love ecosystem because it's a nice, soft, fuzzy term.
I know.
But in business, the real question is who gets to be the apex predator? And I'll leave it there.
All right. Okay, so I have last question, and I don't want to prolong this conversation any further, but last question is that I think we talked about it in the very beginning. What are the features that OEMs want to enable? I think Phil Coltman is the one who kind of made a joke about the butt warming, seat warming.
How can you not make a joke about butt warmers?
Are you guys aware of any other? Holy shit! Yeah, we should make these features available. That's my last question to end this wrap up session.
I mean, I'm looking at a slide that we put together, Junko, only because I can't remember all this, but we've got a list of OEMs, all of them see between subscriptions and mobility services, which are all the things that they want to enable, all the incremental things that they want to enable with SDV, tens of billions of dollars worth of new revenue to the OEM. So long as there's that carrot out there, everybody's going to continue going up that mountain that the analogy that we started with. I don't know if the carrot's going to be at the top of that mountain or if the carrot's just on a stick in front of everybody that's continuing to chase it. But it's to be able to specify what those services are, we could go into some detail, but I think just focus on the top line number, tens of billions of dollars of incremental revenue. That's where everybody wants us.
I like numbers, Phil. I love numbers.
And I like butt warmers,
Let me add to that for the folks listening who didn't get why that's such a joke. BMW famously decided they were going to charge for the butt warmer and everyone revolted, right? And so the issue is, there's this billions of dollars of carrot and that incentivizes things. There's two pushbacks. One is some things people don't want to pay for. Who knows what an e-ticket means? And now look it up if you don't know what I'm talking about because you're just not old enough. And now it's all pay one price, right? So there's a dynamic tension there. And the question is, what can they do that people are willing to pay subscriptions for that don't tick them off because they're seen as a value add? And how, if they have low take rates, how do they subsidize the hardware to support those features of the take rate? Is it high enough? And that's the calculus the car companies have to do. I don't know how it's going to turn out, but that's the calculus that everyone have to work through.
Just to conclude there, look at that from a perspective that we don't know what we don't know. And if you look at the mobile market, who would have expected that today we'll have thousands of applications which can run on a phone 15 years ago, right? Nobody. So yes, we think about the traditional use cases, about the dynamic of the vehicle, about the body features, about the autonomous driving. But in 10 years from now, I'm pretty sure there will be new use cases that nobody thought about it today. So it's just about enabling them with the right technology.
But of course, that means that we're opening the door of the opening the API so that all those independent software developers start developing, and that opens up the whole can of worms of safety. But I think that's a separate discussion. Thanks for joining for the wrap-up session. I think we have plenty of things to go for, and we look forward to seeing you again. All right, thanks. NXP is where the future of automotive begins. Designed to scale and evolve, NXP's system platforms are the foundation for every vehicle architecture. We are innovative collaborators, propelling you forward to spark growth for a future that's dynamic, safe, intelligent, and electrified. Let's redefine automotive together. All right. Well, thanks for
tuning in to the Q&A session. I hope you enjoyed the video, the panel that we just played. And you're in it for a treat because we got 3 guests on this special Q&A session. We got Phil Amsrad from S&P. We've got the Phil Koopman from Carnegie Mellon University. And then we got Brian Carlson, who is standing in for NXP's Sebastian Clamageran. So all-star guest, and everybody's free to ask any burning questions of the SDV. I think we covered a lot of grounds in the video, but I think there are a few outside questions I think that might be brewing among some of the audience. I'm going to start from one aspect. We didn't really cover this. Talk about the electric vehicle. We kind of, for a long time, we kind of thought that the EV is a natural progression from the current ICE to the EEV. So we thought that the kind of EV equal SDV. That was in the back of the mind that we all thought about this. But in fact, there's a lot of chatter going on in the industry right now that we might not jump to directly to battery operated EV. And there are some other steps in between. So tell us, I'd like to ask the panels that is SDV applicable to non-EV as well? And if so, what are the challenges?
Yeah, I could maybe start on that from our perspective, because we actually used to get this question, does SDV equal EV? And a lot of people assume that, and you think from a clean slate with an EV that an SDV architecture makes the most sense. But talking with the OEMs, and there's public statements out there, not just now, but in the past, that SDV will apply to other forms of propulsion, including ICE. And you saw some of the things like Hyundai just recently announced about ICE charging the battery and some really interesting new concepts. So we see still the backbone of new vehicles going forward to be SDV. So yeah, don't have in your head that SDV means EV. And that's been pretty consistent. I think it's been amplified now because of the new changes and delays in some of the EV efforts and bringing more of these propulsion systems into the mix.
Would it make it more difficult if it is applying the SDV architecture to the non-EV architecture? Does it make it different?
So we see a lot of the powertrain, even outside of, even still domain-based, even within SDV architecture. So you can still maintain a level of some the over-the-air updates and capabilities, but still keep it separate. And that's kind of how we're seeing, think of it, the hybrids being hybrid, where you see the powertrain being separate, but can still maintain a lot of the fundamental aspects of SDV, but maybe not implementing into the central computer zone, but as a separate part that maybe is part of the zone or attached to the zone. So they make those things work. It's a little bit more complex, but
all right.
There's an inertia question, but something to keep in mind is that hybrids have basically an EV part of their powertrain, because when you're pressing the brake pedal on a hybrid, or at least the ones I've looked at, when you press the brake pedal on a hybrid, that's merely a suggestion to the computer. There's isolation valves between your brake pedal and those brakes, because if there weren't, regen wouldn't work. Regen only works if you're not applying your friction brakes, right? And so there's a big window, as Brian was suggesting, there's a big window to put the EV architecture into a conventional vehicle as long as it's hybrid. So I think some of this may be more of a matter of degree than a yes/no EV, not EV. There's a lot of gray area. I agree.
In the middle. We've actually shown some modeling about how you manage the efficiency of the vehicle between the BEV part and the powertrain, the ICE part. There's some really interesting algorithms of how you can leverage both of those. And that's the beauty of the software-defined vehicles, updating the algorithms, because there's a lot of work going on in this area of efficiency, right? Range and efficiency. So that's something that the hybrids can take benefit of from an SDV architecture.
Yeah, Junko, I think if you go back to the presentation itself, or the previous recording itself, one of the underlying themes for the success of SDV was developing that at the beginning of the car's
development, it's evolution. So when you talk about, could I put SDV on an ICE car? Yeah, there's nothing that precludes you from being able to do that. However, if you're going to try to do that on a car that's already got 120 ECUs on it, thinking I'm going to update each one of those ECUs because I can, that becomes a bit more challenging than the EV, the hybrid, something that was developed with that architecture in mind.
In mind.
Yeah.
Yeah. All right. Good.
If I may follow up real quick, Junko, these questions, who gets to make these decisions anyway? Is it the software developers? Is it if it's separate from the OEM or from the chip maker, or is it the OEM? Who's making all these decisions in this whole cycle?
Well, I'll jump and then these guys can correct me. We used to diagram the decision-making process within automotive is very hierarchical, that the OEMs made all the decisions, the tier ones implemented it, and then the rest of the supply chain followed suit. Now it's much more of a ball of yarn, in that wherever there's a breakthrough, that influences all the other connected pieces. So, while the easy answer is to say, oh, the OEMs ultimately make all the decisions, well, they kind of are responsible at the top line for everything. But it's really going to, if somebody brings a software solution to them that enables them to do something they hadn't thought of, that goes into their decision making matrix immediately. And whether it's software, whether it's hardware, whether it's system architecture. So now wherever the good idea comes from, they kind of are at the front of this parade until either somebody catches them, it's proven that there's a better idea out there, or it's more likely the case I'm thinking of like the Peloton, where you'll have a couple people out front, and then all of a sudden that Peloton will just engulf all of them, and that's the direction now the whole industry is going.
Yeah, that's a good point. Well, there are a couple of questions from our audience, and this is a little chippy question, but let me ask, do you see chiplets as the enablers for sailing the SDV mountain? Perhaps the only enabler along with advanced packaging? What do you think?
I would say,
I love this dead silence.
I guess I'll say it'll have its place and its time. So right now, fairly young, fairly costly types of things, but you'll see, I think over time, this comes into play, especially in ADAS, ADAS especially, right, where you need to be able to mix and match, and like what was talked about earlier in the session about cost, right? Scalability is key, and whether you do scalability through modules or population options or chiplets and all these, there's a lot of ways of skinning the cat there, but it comes in, I think, at the high level, and then who knows, over time during 2030 to 2040, as we see that propagate through, no one knows how fast that'll come in. I mean, it'll have its play, but does it actually proliferate through the whole vehicle? I think, as was also brought up, cost sensitivity, BOM. Right now, especially BOM is the critical issue, right? Especially with the low cost Chinese cars coming in, everyone's under pressure for cost. So that's one thing that's going to work against it. But at the high end, where there's some more, budget and margin to do it, you start to see it come in, and maybe over time. But I think there's other things. I mean, we're already doing system and package, right? We're doing effectively kind of like chiplets. We're doing system and package.
Oh, yeah.
Multiple dies on the same coplanar substrate. And there's ways to do it without going to a very expensive. In fact, you can do it very cost effectively in other ways, which makes more sense for high performance compute. We're using really high bandwidth memory and things like that. Then chiplets at the high end probably make more sense initially when they do become feasible.
There's another question from the audience. What does a good architecture for SDV look like? Being a software or hardware communication, or, I mean, it's like, can you give us a little picture? What would it look like?
Phil, you want to take that?
So I'm going to say that there's no one right answer. There can be multiple different architectures, because every architecture is a point in the trade-off space. So it isn't a question of which one is the right one. It's a question of, you picked an architecture. Does it get the trade-offs right? and you go into old classic ideas like coherence and like cohesion and coupling, and whether or not the architectural interfaces make sense, and all those kinds of things, and whether pivotally whether the architecture maps onto your organizational structure, and whether which of those you change to fix it, right? Those are the kind of things, and every architecture has to be judged on its merits. And I would not expect to see the same architecture for a company that's trying to make the cheapest in-city, low-cost, whatever. You know, that's going to be a different architecture than something that's supposed to be a living room on wheels, and that's okay. It's a question of whether the right architectural choices have been made, and whether it's a principled approach or it's a bunch of stuff slapped together. I mean, that's how
I agree, and you probably see some of the famous architectural diagrams that are out there that we put out. A lot of people reference, but I think we're up to 8 different types of high-level architectures today. And I always say one architecture doesn't fit all, but saying that within one of those architectures, or within the major classes of architectures, you can actually design in a way that's scalable, right? So the key to me, as OEMs are looking to invest, they don't want to rip it up in 2 or 3 years and start over, right? So they have to have a way that invests, the right silicon that scales, not one chip that doesn't scale, but an architecture that scales. So on a hardware side, it's really, really important. On the software side, it's really about putting in that service-oriented architecture, because that scales, right? It's about not signal-based and CAN, it's about Ethernet, things like some IP and DVS, and actually having the software architecture in place, because that architecture will scale no matter where you are in the vehicle. That gives you the flexibility to do some amazing things, and it doesn't lock you into something that doesn't scale down the road. So they have to think both sides. I agree, it's hardware and software, and there's a lot of considerations on both sides there.
And to be clear, there's a second edge of that sword, that if you pick a scalable hardware architecture, but you put the wrong software architecture on it, you're going to get scalability bottlenecks that the hardware won't fix.
Mm-hmm. Yeah,
I kind of like this question from one of our participants. It seems like an obvious kind of question, like, will SDVs actually enhance or diminish functional safety? What should it really be doing, and what is it projected to be doing now?
Well, for that one, it's a question of you have multiple architectures. I sort of led up to this one, but let me go deeper. Any architecture has multiple facets, multiple ways of looking at it. And you can talk about it as having different, you can have a software architecture, you can have a hardware architecture, you can have a control system architecture, if you're doing the controls, and you can have a user interface architecture. All those architectures have to be done in a principled way, or you'll have problems of different types. And all of those architectures have to map onto the same system, because you're building the one thing. You're just coming at it. There's one view over here and one view over here. And those different views all have to be looking at the same thing. And if you have views that don't match well, you get a really nasty architecture that doesn't work. One of the things you need is a safety architecture. And as a practical matter, you start asking questions like, okay, so you have this software architecture, you have the hardware architecture. How do you map the software modules onto the hardware modules? And are there any software modules that are supposed to be redundant for safety that ended up sitting on the same CPU with the same power supply? Well, that's not going to work. And so a lot of this is looking at the different mapping interrelationships among the different architectural viewpoints.
Yeah, and that's part of the automotive functional safety, just like security, right? You do the analysis up front. And there's things now too, like the safety availability. That's a whole nother issue, because there's some functions like brake-by-wire, steer-by-wire, that availability is critical if it's not available, where there's other safety functions that don't have quite the availability issues, but are still functionally safe. There's a lot of complexity that goes in, but he said the right thing there. It has to be designed up front, and it has to have safety, functional safety architects and experts up front. And so SDV, it's no different than a traditional architecture from that perspective. So there's a lot of things under the covers that we don't talk about that goes on in the chip. It's amazing stuff, right? A lot of complexity goes into these chips related to doing this, and software, functional safety software frameworks that actually manage that dynamically, and how the PMIC works with the chip itself. There's a lot of under the stuff going on there that works into it. So SDV has the same challenges. They have to, right? I can't put an SDV out that has less functional safety than a vehicle today. I can't. It won't. And so there are methodologies, there are techniques, there are technologies, all that goes into it. And the architecture up front is the most critical part, because you have to get that up front, right? And so that's done. That's the natural process of designing an automobile, right?
The simple answer is it has the potential to be better, but it's harder to make it acceptable. It's more complex.
Yeah.
And it gives you some upside. Like you said, it does give you some upside capabilities, because now you have a lot more technology built in these devices to support it, to monitor it, to do real-time failure analysis before it even happens, as well as how you can adapt the safety over time, which you had no way to do that in the past. So I would say at the end of the day, it's more difficult to achieve, but it's achievable. People are doing it, and it gives you a huge upside on the back end once the vehicles are in production.
You know, one of the things that I wanted to ask was during the video, Phil Coltman talked about, well, we were talking about how the pendulum swings from centralization versus distributed architecture, and pendulum swings, right? And you said you have seen it other industries or other systems. Tell me the examples, and how is it different, or how is it the same?
There was a great example in the 90s for jet engines that somebody said, you had this 68020 or whatever it was, and you know, they have a central computer, and if we distribute the computers, we can buy lots of computers, and in a jet engine there's a big box, like big box, okay? And one of the specifications for this box is the computer has to work while it's on fire for 10 minutes soaked in burning jet fuel. You know, some really interesting specs here. And they have two computers, and that box is a packaging problem, because the engine cowling has to go around it. And so maybe if you had a lot of little boxes, they would fit in all the nooks and crannies, and you can make the nacelle a little bit smaller around the engine. And then you say, okay, yeah, so you can basically make the engine little smaller profile and reduce drag, right? And it's like, but you know, one of the things about that box is it's cooled. It's liquid cooled. It's cooled with jet fuel is what it's cooled with. And so now if you have 5 boxes, each one of the 5 boxes needs a jet fuel liquid cooling interface, because the engines are hot and the electronics doesn't like the heat. And now you have a wiring harness that has to go to all of them, and that can break. And you know, so this is why I keep saying it's never as simple as you think. But that was my first experience going into this, right? So, and I've seen this in jet engines, I've seen it in elevators, I've seen it in cars, I've seen it in air conditioners, I've seen it in electronic controls, and it's always the same discussion, always.
Yeah.
Oh,
but you know, just look at compute itself, right? We started out with mainframes, we moved to PCs, then we moved to the cloud, right? The pendulum is always moving in every industry. And I would say even within automotive, right, there's trade-offs, there's pros and cons, but it's not, there's definitely gray areas in between it. It's not one or the other. So I want to be really cautious when we talk about central compute. I don't see that as the reality, right? It is not central compute. It is still distributed. It's distributed in a different way, which gives significant advantages. It's not distributed and locked up in 150 boxes or 100 boxes. It's distributed in a much more intelligent way that gives you the flexibility to grow and provide value, right, that you can't do with the way distributed is today. But I totally agree. This is always the issue of a pendulum and everything. So I totally agree with it. I just think there's gray. It's not all black or white. Right.
Well, and the pendulum spends most of its time in the middle, as you would expect, and that's okay.
All right, stuck in the middle. You know, I have a question about, I think it was Brian who briefly mentioned China, and it's always an elephant in the room. And we are aware that how, you know, whether good or bad or how advanced they are. I mean, Chinese are really hot to trot of autonomous vehicle as well. And Phil Amstrad, have you seen any examples of the Chinese vendors or, you know, OEMs really hot to trot for SDV so far?
You know, I know the title of this topic is SDV. What I don't think that translates to from an OEM's perspective is I've got an SDV initiative. I need to build an SDV car. But it is implicit in all the architectural discussion. So to Brian's point, When we first started looking at the trend towards centralization, we had discrete ECUs going to domain controllers, going to a single centralized computer. And as we dug into that more and more, it was all a bunch of hybrids. That's where we're at right now. There's a regional component, there's an OEM component, there's price components. So what the Chinese, I would say, are focusing on is both trying to build a lower cost solution. So you've got the $10,000 car initiative, and they're trying to keep up with Tesla in terms of that level of technical performance. And then those are kind of the two poles, and then everybody's occupying the space in between. But everybody's sensitive to software. But I don't know that anybody's pounding the table saying, if this isn't SDV, I won't have it. But when you look at what they're trying to accomplish, if they don't have SDV, they can't do it.
I see. Yeah, that's a good question. We can go on forever, but we need to wrap it up. But I think there's one good question that to conclude, I don't need a whole bunch of examples, but if you have to say one benefit of SDV for consumers, one benefit for OEMs, can you explain what it is?
Yeah, I think from the OEM side, because I was in conversations, I can remember 2016, even the first conversation I had with one of the OEMs about their goal, what they wanted to be able to do. And I think the availability, the ability to get into everything that's going on in the vehicle is critical, because we were told back in the day, and still probably most of the day, they had to make test harnesses and special vehicles to do quite a lot of stuff. And to me, that data-driven, these are software-defined, but data-driven, to me, from an OEM point of view, that data-driven aspect, and they wanted to be able to access from anywhere in the world, every vehicle, and be able to optimize their design, to be able to understand how vehicles are being used. That's really critical because of low margins, and where do I invest my money in my vehicle? These are types of conversations we had 8 years ago. And I think the reality is now coming true. So I think from that aspect, SDV is critical for them for that. On the consumer side, I think it's really about that personalized experience, really, that this vehicle is, it's not something you just get and that's what you get. It's something that can actually personalize and adapt to you. And now with all the other stuff that's going on with AI, right? There's quite a lot of AI going into these things, dozens of AI models and such. But there's ways that it'll adapt and improve over time. And I think for the consumer is that they're excited that that vehicle will get better over time. It'll be more personalized to what I like. Even the ride, the feel of the ride, how it interacts with you, how it actually automates things that you want to do. That's the big benefit to the consumer, I think. It really transforms what an automobile is, right?
I remember Phil Armstrong told me that he actually likes it, butt warmer feature of the SDV.
The fact that you can turn that on and off at a moment's notice is just, it's the pinnacle of human existence.
But seriously, what is what is the benefit for OEMs then? Is that a flexibility of the architecture, or what do they give them?
On the one hand, you hear the OEMs talk about it's a brand new revenue stream. I'm a little skeptical of that, because while it does give examples of potential revenue streams, I don't know that it's going to generate the tens of billions of dollars that some people have been forecasting. I do like what Brian just said, the access to data. I think that is something, because right now they're limited in that regard to what buy decisions do people make when they buy that car. They never know after that, do you really use your sunroof? Do you really use these features? And therefore you're continuing to guess, what do people want? What are they willing to pay for? And I think if they could get some access to that information in real time, obviously privacy concerns withstanding, that could be very useful to the OEMs. And conversely, I think, for the consumer, again, I agree with everything that Brian just said, and then add to that the possibility for adding, butt warmers whenever you need them. But more importantly, you know, when my phone gets a new feature that prevents me from having to go out and buy a new piece of hardware, I just take that for granted. I think now that same feature is going to come to the car, that, you know, why does my car feel stale? Because it's got, you know, it's limited to the apps that were installed 3 years ago when I bought it.
Yeah, that's there's to that. What about you, Phil? Copeman?
Two-part answer. The second one's more serious, so don't everyone jump off. We haven't talked about security net much, but you know, because this is one of my favorite topics. Just imagine an attack that goes, awful nice butt warmer you got there. Be a shame if something happened to it.
Yeah.
Moving on to something more serious. The benefit I see is a little more abstract, a little higher level, but it's actually something that's super important. And that is, for years and years and years, it's almost as long as I've been at it, and I've been doing car stuff one way or another for decades, it's been apparent that software keeps growing. And at first it was, you know, a couple lines of code, and then the one microcontroller hobbyist geek in the back who taught himself, and he programmed it in, and he had 400 bytes of memory, and, you know, have fun with that. And it was fine because it had some value. And then over time, what we see is, and this is true of all the industries I've worked with, automotive is just the one currently at this point, that over time, the amount of software increases, the amount of digital hardware increases, the amount of electronics increases, and it stops becoming one guy in the back room. It starts becoming measurable in headcount. It starts becoming a driver of revenue and value add. It starts becoming, we woke up one morning, this is from a rail story. A manager told me, we woke up one morning and half our headcount was software. How did that happen, right? And so automotive is going down this path where software, in terms of expense and headcount and value, and with the electronics and all that's been growing, it's been inevitable that software will be the elephant in the room. And the industry has had to transition from software's this little tiny hair on the tail of the dog, and now you know, software is sort of the thing that's delivering, and that's okay, because the rest of the world has already been through that, or some of the world is about to go through that. You know, this is just how things go, and there's the whole idea of software is eating the world. Well, yeah, that is actually what's happening, and so the question really is, what's SDV doing? What SDV is the recognition that that's happening, and it's about time. So I'm glad that SDV is putting the whole software question up front and center, so companies can deal with it in a rational way instead of sweeping under the rug. So for me, both for customers and companies, that's the big value.
All right, very good. Well, we could go on, but we must move on to another session. But thank you so much for your time. It was a lot of fun, and we will see you soon.